Okay, so now let's just take a look at how to find the resultant force when they give you the angle between two forces. Okay, so with this, they are going to give you the angle between two forces. Then they'll give you the magnitude of the two forces. Then they'll ask you to find the magnitude of the resultant force. Now this is how you solve for it. So first, let me take this over here to be the magnitude of the first force, the force 1. Okay, so the force 1 will come down here. Take note, it will come down here. Now let me have my force 2. So now the force 2 will be in this direction. So this is the force 2. So now this is the magnitude of the force 2, the magnitude of the force 1. Now with this, if you add these two vectors over here, the resultant vector is what you see over here. So now this is going to be the, the resultant vector. So I have the magnitude of the resultant vector. Now I can transpose this vector up here and transpose this vector over here to get this parallelogram. Now from this over here, usually with this type of questions, they are going to give you the angle between the two forces. That is the force 1 and the force 2. And then they are going to ask you to find for the resultant force. Sometimes they will give you the magnitude for force 1, then the magnitude for force 2, then they will give you the magnitude for force 3, then they will ask you to find for the angle between the two forces. Okay, so now this is how to tackle these type of questions. So let's say we have the theta over here to be the angle between the two forces. Then from, because this line over here is parallel to this line over here, now if this is theta, then this angle over here should also be 180 minus theta. So because they are co-interior angles. Okay, so these two angles over here, so this angle and this angle over here, they are co-interior angles. That is the whole of this angle, the whole of this angle, and the whole of this angle over here. They are co-interior angles. So co-interior angles sum up to 180. So it means that if this is theta, then this should be 180 minus theta. Okay. Now with this, if you want to find for the angle between the two forces, right? So now I am going to consider the triangle, so this triangle. So the triangle that I am marking with the red ink, that is the triangle I am going to consider. Right. So now if I have this triangle over here and I want to solve for my theta, now I am going to use the cosine rule. Now remember that with this, I don't have a right angle triangle over there. So I cannot use the trig ratios or the Pythagoras theorem or whatever. So with this, we have to use the cosine rule. So with the cosine rule, and this is the rule. Now it is a resultant force, that is this force over here, the resultant force over here squared is equal to the force 1 squared. So the force 1 squared plus the force 2, so the force 2 squared minus 2 times the force 1 times the force 2 times the cos of 180 minus theta. So now this is the formula that we are going to use to solve for the magnitude of the resultant force. So again, it is the resultant force squared is equal to force 1 squared plus force 2 squared minus 2 times force 1 times force 2 times the cos of 180, so 180 minus theta. So now this over here that you see, it is just the angle over here. Okay, it is just this angle, and always the what comes over here is supposed to be opposite to the angle over here. Okay, so over here, because the resultant force is opposite to the 180 minus theta, that is why we have it out here. So now this is the formula for the resultant. force. When you are given the angle between the two forces and the magnitude for the two forces, and then you're asked to find the magnitude of the resultant force. Okay, so let's take a look at this question over here. So this question, it says that the angle between two forces P and Q, so that is force 1 and force 2, acting at a point is 40 degrees. So the angle between the two forces is 40 degrees. If the magnitude of P and Q are 12 newtons and 8 newtons respectively. So now we have been given the magnitude of the force P and the force Q. Now we are to calculate to 1 decimal place the magnitude of the resultant force and then the angle which the resultant force makes with the force P. Okay. So now this is the question that we've been presented with, and we have to solve for first the magnitude of the resultant force, then we will find the angle between the resultant force and the force P. So with this, now this is how the diagram is going to look like. Okay, so we have the force 1 as 12 newtons, the force 2 as 8 newtons. Now the force 2 over here will be the same as this over here, that is 8 newtons, and the force 1 will be the same as this over here, that is 12 newtons. Then because the angle between the two forces is 180, it's 40. So this is the angle between the two forces. So this is 40. So force 2 goes in this direction. Force 1 goes in this direction. The angle between these two forces is 40. Then the angle over here is going to be, remember that it is 180 minus theta. So in here our theta is equal to 40. So it is going to be 180 minus 40. That is going to give me 140. So from here we are going to use the cosine rule to solve for the magnitude of the resultant force. So the resultant force squared is equal to, so the force 1 squared plus the force 2 squared minus 2 times the force 1 times the force 2, then the cos of 140. So from here, when I square 12, I'm going to get 144. When I square 8, I'm going to get 64. When I multiply these numbers over here, I'm going to get 192. Remember that the sign over here is negative. Okay, very important. Then, so when I add this, I'm going to get 208. Now when I do cos 140 and I multiply that by 192, I'm going to get negative 147. Okay, so this over here is going to give you negative 147 because the cos of 140 is going to give you a negative number. Okay, so you multiply that by the positive 192, you're going to get negative 147, and there is a negative over here too. So there is a negative over here, as you can see, it's a negative over there. So now negative times negative will give me a positive number. Now when I put these two together, I'm going to get a result to be 355.08. So that is the resultant. So that is the resultant force squared is equal to this. So now I have to take the square root of both sides. When I take the square root, I'm going to get, so the square root is going to give me, so 355.08 is equal to, so the square root of this is going to give me 18.84. That is going to be the magnitude of the resultant force. So therefore it is giving us, so 18 point, so we have to have our answer to 1 decimal place. So it is going to be 18.8 newtons. Okay, I think there's already a unit for that. So it's supposed to be newtons. So N, because I'm talking about forces. So 18.8 newtons. Okay. So that is how to find for the resultant force. So first, so you just use this formula over here. Okay. You just use this formula over here. So the resultant force squared is equal to force 1 squared plus force 2 squared minus 2 times force 1 times force 2 times the cos of 180 minus theta. So 180 minus theta is this. Then we have the force 1, we have the force 2, then we have, so we have to find for the resultant force. So this is going to be our end results. So next you have to find for the angle between the resultant force and the P. So now this is our P, right? This is the force P. This is the resultant force, right? So now I am representing the angle between the resultant force and the P as alpha. Okay, so now this is the angle between the resultant force, and then the vector P, right? So this is one. So now you realize that we have a triangle. So this is a triangle. So this is a triangle. Now this angle over here is opposite to this, and you can see that the angle alpha, so this angle over here alpha, that is opposite to this over here. So with this I can use the sine rule to solve for this. So from the sine rule, so I have the alpha to be opposite to the 8. I have the 180, that is the angle over here, to be opposite to the 18.84. So when I use the sine rule, so I just make my alpha the subject. So I move the 8 to this side. So I multiply through by 8 to get this. Now when I punch this whole thing in the calculator, I'm going to end up with this. Then I take the sine inverse of both sides. So alpha is equal to the sine inverse of 0.2729. So therefore, alpha is equal to 15.837 degree. But we have to leave our answer to one decimal place. So therefore, the final answer is going to be 15.8 degrees. So this is our final answer. So that is our final answer.